This is Dr. D. Govardhan, Professor and Dean, Department of Aeronautical Engineering, Ministry of Aeronautical Engineering, Hyderabad. Today, we are discussing the radiation properties in heat transfer. When a radiant energy or the energy incident on a body may be generally, this may be used in three ways. The part it may be reflected, the part may be observed, or it may be the transmitted. That means when an object, when an energy is there, we need the incident on this object. If a Q is there, that is the total energy incident on the surface. This total energy, part of this total energy may be observed by this body depending on its characteristics, or it may be partly reflected, or may be partly transmitted into it now. The fraction of the incident energy that is observed by the body is called absorptivity of the surface. It is denoted by alpha. The part of the energy which is reflected is called reflectivity. Here the part means if Qt is representing the energy that is reflected by Q, that is the total energy, the ratio of the energy which is reflected to the total energy is called here reflectivity. Similarly, the part of the energy which is transmitted to its total energy, it is called transmittivity. Generally, it is represented as tau. So, the total energy is equal to, according to this relation, so we can write it now. Here, QA is representing the quantity of energy that is observed divided by Q. This is called absorptivity. Plus Qt divided by Q, it is called reflectivity, and Qt divided by Q, it is a transmittivity. The sum is nothing but equal to Qa plus Qr plus Qt divided by Q, or it is nothing but equal to 1 now. Or in other words, that is alpha plus rho plus tau should be equal to 1 now. That is the sum of the observability, reflectivity and the transmittivity should be equal to the 1 now. So, for generally for all the surfaces, alpha plus rho plus tau should be equal to 1 now for all subjects. But if the opaque body is there now, that is the transmissivity is equal to 0, that means alpha plus rho should be equal to 1 now. That is represented here in equation number 4 now. For block surfaces, it will not reflect any energy or it will not transmit, it only absorbs. Hence, for the block surfaces, alpha is equal to 1. Kirchhoff's law. This law states that at any temperature, the ratio of total emissive power E to the total absorptivity alpha is a constant for all substances which are in thermal equilibrium with the environment. A thermal equilibrium means here the total energy, that is, it will not transfer from one body to another body. That generally it occurs when both the bodies are at the same temperature. Here, consider large radiating body of surface area A, it is shown in figure, it is there, A, which encloses a small body of surface area A1. That is A1, it is a small body which is enclosed in a larger body A as shown in figure. Let the energy falling on the unit surface of the body at the rate of EB. EB is representing, that is energy which is falling per unit surface. So, of this, generally the fraction alpha will be absorbed by the small body. Thus, the energy absorbed by the small body is equal to alpha 1, A1 and EB now. Where alpha 1 is representing that is a part of the energy that is absorbed by the body. A1 is equal to the total area of the inner object, and EB is that is the energy that is absorbed by the A1 per unit area. Hence, total energy is equal to alpha 1, A1 and EB. This is the absorbed by the A1 values now. When thermal equilibrium is attained, the energy absorbed by the body must be equal to the energy emitted now. Hence, here we can write it now. A1, E1 should be equal to the alpha 1, A1 and EB now. So, this is the equation number here 1. Now, if a body is replaced by 2, that is another body, having observed alpha 2, the same equation it can be represented as A2 E2 is equal to alpha 2 A2 EB now. So, from this relationship we can write it now. EB is equal to E1 by alpha 1, which is equal to E2 by alpha 2, or it can be written as E by alpha. So, as per the definition of emissivity, it can be defined as emissivity is equal to E divided by EB. So, the emissivity of the body is equal to the absorptivity when the body remains in thermal equilibrium with its surroundings. That is, here now, emissivity is generally represented area epsilon. It should be equal to alpha. The concept of shape factor. Okay, this is the important term generally used in transfer of heat from one body to another body when they are at different temperature by using the radiation process. So, the thermal radiation from a surface travels all over the space in all directions about the surface. Here, for example, for this one, if you take this object is there which is in the form of ball or globe, the heat energy is radiated from its entire surfaces in all directions. Certain portion of radiant energy emitted by the surface which reaches the other body can be observed or transmitted or reflected by the body depending on characteristics of the objects. The fraction of energy emitted by the body that reaches the other body can be calculated if the absorptivity of the surface is known. So, case 1, black body will all the incident energy will be absorbed, and the second one, effective grey bodies part will be absorbed and part will be reflected. That is, transmissibility is equal to 0 now. The part of the reflected energy may be again reach the original body, which will be disposed of as the original radiations. The shape factor is defined to facilitate the study of new concept. Here the energy here now it is there higher temperature. This energy it is there now. When one more object is kept which is an effective, what are the energy that is incident and second from one? The part it may be observed or part may be the reflected now. But here from the body one also just the amount is here when it is incidenting, that nothing but here it is also having here observed that the reflection is there now. But this energy is also because of effective body, some energy is again reflected to other surfaces. So the total energy which is transmitted from 1 to it depends upon the net energy now. But in order to study what is the net energy that is transmitted from 1 to 2, the shape factor is the most important, which is the facility to study the concept. Because here according to our previous one, the energy always flows from the higher temperature to lower temperature. Here, but in this case, the second body because of its properties, it also reflected some of its energy towards one. Hence, net energy can be calculated if you know just by using the concept of shape factor. Here, the radiation heat exchange between two bodies is influenced by the following three parameters. Here, one is there now. This assumed yes, it is a source which is having higher temperature. The energy is now transferring to the bodies 2, 3 as well as the 4 as shown in figure. But according to the earlier discussion, the heat energy is radiated from its surfaces in all sides of it now. But that's why we are considering this body is here energy is transmitting only from the bottom surface of the body 1 as shown in figure now. So the amount of heat energy that is transmitting from body 1 to second and third and fourth bodies, it depends upon the temperature of the individual bodies. The second one is radiation properties of the individual bodies such as emissivity. Third one is the orientation of the bodies relative to each other. First one is okay, temperature difference is there now, it depends upon. The second one is it depends upon the properties of the body, because we are classified the bodies into here now 3 types now. Block body, which will observe all the energy which is incident on it now. And one more is the opaque body. In opaque body, the energy will not be transmitted here. It is reflected partly is observed now. And one more is here white body. All the lights which are falling on it is reflected now. But depending upon this how much amount of that energy it is absorbed by this 2, 3, 4 from 1, it depends upon the type of the characteristics of the body. Third one is the orientation of the bodies. Here orientation means here it may be the rectangle, it is there now. The second one is the triangle, it is there. Here from the surface it only this base is nothing but only toward the light, but sometimes the surface is also there now. That what is the orientation, that is also playing vital role in transmitting energy from one body to another body. That means what we are calling orientation of the bodies related to each other. The effect of orientation of the bodies on radiation heat transfer is accounted by considering the factor is called configuration factor, which is also called shape factor. It is also called view factor also. So configuration factor. Now let us consider the body 1 here, which is emitting the radiation from its bottom surface only. And a part of this radiation is intersected by the 3 bodies 2, 3 and 4 as shown in figure. The configuration factor between 1 and 2 denoted by F1, 2 now. That means here the factor from 1 and 2 means the energy is flowing from the body 1 to 2 now, where F is representing the shape factor or configuration factor or the V factor. And it is expressed as F12 is equal to that radiation of energy received from the body 1 to 2 divided by total energy radiated by the body 1 now. That is how much energy that is flowing from 1 to 2 divided by the total energy, that is called Q now, which is emitting from the body 1. So this is called here now F1, 2 now. Similarly, if 2, 1 is representing now, that is the total energy that is radiating toward the body 1 now. Assume from 2. That means here F21 is equal to, that is the shape factor from 2 to 1, that is the energy is flowing from the second object to first object. It is given by radiation energy received from 2 of the body to 1 now, that is from 2 to 1 divided by total energy radiated by the body 2 now. So similarly, the configuration or shape factor between 1 and 2, 1 and 3 can be expressed as F13. That is F13 means the total amount of energy that is radiated from 1 to 3 divided by total energy radiated from 1. Similarly, F14 is representing the total energy received by 4 from 1 to the total energy radiated by the 1. The configuration or the view shape factor depends upon the geometry or shape of the bodies involved in the radiation of or heat exchange and independent of the surface properties and temperature of the bodies now. Because already we are taken now, the shape factor is equal to F1A2 is equal to, we are taking Q12 divided by Q now. That means it is purely depending upon that is the shape of the bodies which are just exchanging energy from one to two position, but it is independent of surface properties as well as the temperature of the bodies. Shape factor special cases now. A mathematical expression for configuration of the view of shape factor can be obtained by considering two bodies 1 and 2 exchanging heat by radiation when maintained at a temperature T1 and T2 respectively, where T1 is representing the temperature of the body which is at a higher temperature, assume T2 is representing the temperature of the body which is maintaining at lower. That means the heat energy is flowing from body 1 to 2 position. These two bodies are at a distance of s from each other and having areas A1 and A2 respectively as shown in figure now. Here it is the A1, A2, A3 and A4. So the total heat radiated from 1 towards the 2, that is given that energy received by 2 from 1, it is equal to F12. F12 is nothing but representing the shape factor from 1 to 2 position multiplied by A1 into sigma T1 to the power of 4 minus T2 to the power of 4 now. Where F1, F2, F12 is representing the shape factor from 1 to 2, that is the amount of fraction of energy that is received by 2 from the 1 now. So this is nothing but representing the total energy radiated from body 1 towards the body 2 now. Similarly, that net energy lost by body 1 must be equal to the energy gained by the body 2, because when you are considering only 2, and Q12 is equal to, we can take it as here, that is energy received from 1 to 2 is equal to the energy absorbed is equal to 2 to 1. Both are equal, but the second one is at lower temperature, hence the energy is flowing from 1 to 2, it is represented as negative signs, that is Q12 minus of Q21 now. That is here T2 is greater than less than T1 now. So from these equations now, F12 A1 sigma T1 to the power of 4 minus T to the power of 4 should be equal to minus of F21 A2 into sigma, that is T to the power of 4 minus T1 to the power of 4 now. So from this relationship we got it now, that is F12 into A1 is equal to F21 into A2 now. So this equation is known as reciprocal relationship between the shape factors. For the shape factors, already just given these informations, so many terms also used synonymously, such as angle factor, V factor, geometric shape factor. These are the important terms generally used in a radiation process. The shape factor depends upon the geometric position of the surfaces. If the second two encloses the surface 1 completely, then the shape factor from 1 to 2 is equal to 1 now. If two surfaces are kept far away in such a way that they are not visible from each other, then the shape factor from 1 to 2 is equal to 0 now. The shape factor depends upon the distance between the surfaces and the area of the surfaces. The two coaxial circular discs facing with each other will have a higher value of shape factor if this move closer to each other. For the same central distance, larger area will have higher shape factor. Okay, based on the shape factor, Here we are taking one problem, The problem number 1, determine the shape pattern from the base of a cylinder to the curved surface. Also find the shape pattern from the curved surface to the base and then the curved surface to itself. Okay, the given data in the problem is the diameter is given 1 meter now. The diameter of the cylinder is given 1 meter and the height is also given here 1 meter. The base one is enclosed by the top, that is the 3, and the curved surface 2. Here curved surface 2, here the top now, here A1. That is nothing but here now, the diameter is 1 meter, it is given. The base one is enclosed by the top surface, which is represented as 3, and curved surfaces, that is A2. These are the given. Hence, F12 plus F13 should be equal to 1 now. F1 to 2 plus F13 should be equal to 1 now. F13, it can be determined by using the chart for parallel disc now. This is nothing but, if I observe, this is nothing but the two are now parallel to each other now. So the ratio of diameter by the distance between the planes, here it is equal to 1. That is the diameter divided by 1 is equal to 1 now. Generally, here F13, it can be determined by using the chart, but by using the relations to the ratio of the diameter to the distance we have to measure, it is equal to 1. The corresponding value for the shape factor according to the chart is equal to 0.17. Hence, according to the relations of F12 plus F13 is equal to 1 now. Since F13 is nothing but already we determined its value is equal to 0.17, and the remaining value is F12 is equal to 1.0 minus 0.17, which is equal to 0.83 now. So using the reciprocity theorem, A1 F12 is equal to A2 F21, because already we determined these equations in the previous case. From this relation, so A1 is nothing but the area of the bottom of the cylinder, which is equal to pi d square by 4. Pi d is equal to 1 into 1 divided by 4 into F12 is equal to, already we determined it is equal to 0.87. It should be equal to pi into 1 into 1 into F21. From this relation, so F21 is equal to 0.2175. This is our required answer now. Now consider the curved surface as the concave surface will intercept some radiation from the surface itself. Hence, here F21 plus F23 plus F22 is equal to 1 now. Here we are now taking the curved surface as the source for the radiations. So the energy which is flowing from 2 to 1, from 2 to 3 plus itself is also there now, 2 to 3, 2 to 2 should be equal to 1 now. But F21 already we have determined it is equal to, F21 is equal to F23, both are equal. F22 is equal to, we can take it as 1 minus 2 into 0.2175, which is equal to 0.565 now. The concave surfaces intercept the part of the radiation emitted by themselves. Here it intercepts more than half of the radiation, according to these equations or the calculations. Here problem number 2 now. Two parallel rectangular surfaces 1 meter by 2 meter are opposite to each other at a distance of 4 meters. The surfaces are black and 100 degrees centigrade and 200 degrees centigrade respectively. They are maintaining. Calculate the heat exchange by radiations between the two surfaces. Okay, the heat flow between two surfaces is given by Q12 is equal to, according to this, A1 into F12 sigma T1 to the power of 4 minus T2 to the power of 4 now. So here now that epsilon 1 equal to epsilon 2, which is equal to 1. Why? Because these two plates are now kept parallel to each other now. So from B is equal to, just we have to determine the constants from the chart now. This relation is already we taken in the previous problem also. The ratio of this side to its distance, parallel distance we taken. In previous case, it values is equal to 1 by 1 is equal to 1 we have taken. But in this case, B is equal to A by H, where A is nothing but equal to this length of the one of its, that is here side of the rectangle, which is equal to A by H, 2 by 4 is equal to 0.5 now. Similarly, C is equal to B by H now. Then one more side is there, 1 now. The distance between them is equal to 4, which is equal to 0.25 now. So, B and C are there now. That is, the shear factors values can be determined by using the chart, which is equal to F12 is equal to, we can take it as 0.2043 now. Hence, Q12 is equal to, here now, the equation is A1. A1 is equal to area of the plate now, which is equal to 2 by 1. Okay, 2 by 1. Again, F12. F12 is equal to already we determined from the table, which is equal to 0.043 into, here now, sigma is there now, Boltzmann constant, 5.67 into 10 to the power of minus 8 it is there. Hence, here now we are taken the values now, the temperature. Temperature generally it will be converted into the degree of Kelvin. So, when we are taking that values inside it now, we are taken in terms of doing the calculation 4.73 to the power of 4 minus 3.73 to the power of 1. Otherwise, we can take directly this values is equal to into 10 to the power of minus 8 into 473 whole square minus of 373 whole square like this now. On doing this calculation, so we got to Q12 is equal to 149.7 watts. Okay, these are the simple problems we have taken to explain the concept of shear factor. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.